Hello and welcome to this webinar on network design for FTTx, where I will show you how you can use the FiberPlanIT Designer in your FTTx project. My name is Jonas Verstuyft and I'm a business development engineer at Comsoft for FiberPlanIT, and I will be your presenter for this webinar today. Let me first give you a short overview of which topics we will handle in this webinar. So I will start off with a short introduction on FiberPlanIT and how it fits in the planning and design workflow. Then I will handle a couple of different topics in network design, where I will use FiberPlanIT to demo these topics. I will show you how it can be used for initial design, for fine-tuned design, and then I will also show a particular example on Fibre-to-the-X where it can also be used. Then at the end, there will be some time for questions and answers. Some practical details on this webinar first. So the duration of the webinar will be around 45 minutes to an hour. You can ask questions in the Q&A window of GoToWebinar, normally on your right. These questions will be treated at the end, where we'll try to answer as much questions as possible. If I did not get to your question, then I will treat it after the webinar personally via email. At the end of the webinar, you will be directed to a web page where there will be a short survey. It would be highly appreciated if you could fill this survey. Then later this week, I will send out, you can expect an email with a link to the recording of this session. So let's get started. I will first show you a bit an FTTx project workflow and position FiberPlanIT within this workflow. So if we have a look at the complete planning and design process of an FTTx project, first of all, normally you start with the strategic planning phase, where you try to estimate the budget that you will need for doing your FTTx project, for doing your deployment. You define your design rules that you want to use, so the architecture that you want to build out, and also decide where you want to go and what time you want to go there. So you put together your plan for the coming years of your rollouts. Then, if you have decided to roll out your network in a particular area, you will do an initial design for this area. So you will decide where to put your cables, you put your ducts, where you can do your trenching, where fiber concentration points should be located, and so on. Then this initial design can be taken to the field to do an inspection if it is a feasible design, if everything can be built out the way that it was designed. Normally you will have to make some changes to this design, so you will get back to the office to fine-tune the design that you made and turn it into a detailed design where you have your splicing schemes, construction plans, and so on, so that you can actually do the build out and then also store the information. So store your complete network that you built into your network inventory tool. This is a bit the end-to-end process. Now, where does FiberPlanIT fit in? Well, for the strategic planning stage, we have the FiberPlanIT simulator. And this product was covered in a webinar we organized last week. In the mail I will send out, I will also send out a link to this recording so that you can review it. Then for the initial design stage and the fine-tune design stage, we have the FiberPlanIT Designer, which will be covered in this webinar. Then for all the other stages of the process here. We have integrations with engineering inventory tools, or also with solutions for doing the field surveying. So if you have any questions about this, please do ask them as well. Now, how does FiberPlanIT work? Well, we need two types of input data to start with FiberPlanIT. One is the GIS data. So this means we need to know the locations of the streets of any buildings, or and also know the amount of homes there are inside the building. If you're doing an aerial design, you can load in pole information into the software. And we also support the usage of existing conduits which are empty. Then within FiberPlanIT, we have some automatic pre-processing steps. So starting from the streets, we can automatically generate possible trenching locations by the side of the street and take into account the width of the street. Also for aerial, we can automatically connect poles to each other and then provide the lead-in to the building from this pole. And all of this information can still be edited to make sure that local conditions are taken into account. Next off, you need to define the design rules. So you need to load in the different unit cost information for the equipment that must be used for rolling out your network, and also define the architecture. So any type of restrictions to your FTTH design, or if you're looking to deploy a PON network. We also need to know where splitters need to be located and what type of splitters need to be placed. Then FiberPlanIT takes this information into account, so it then applies the design rules, taking into account the costs as well to lower the cost of your design, and applies this to your GIS input data of the area, and comes up with the design. So it will then tell you where trenching is needed, what type of cables and ducts need to be deployed in these trenches, or if the cables need to be placed aerially or not, and also the locations of any fiber concentration points. And all of this will be generated from the point of presence to your to all of the demand points, all of the buildings in case of an FTTH design. And next off, it will also generate a detailed bill of material with a breakdown for all types of equipment, what the needed volume is, and the needed cost for building out your network. Then the FiberPlanIT Designer also allows for still fine-tuning your design, and putting in extra restrictions, so to locations of any distribution cabinets, or any type of connection of a building to one of these cabinets, and then we'll try to re-optimize your network taking into account these restrictions. Then at the end, you can choose to export this information to your network inventory management tool. Okay, so now I will explain a bit how this is done in a bit more detail. So for the initial and fine-tune design, how you can use the FiberPlanIT Designer. So let's first check the initial design. So the objectives here is already to decide on your topology following the design rules that were specified. So any questions that you may have in this stage is, where do you put your fiber concentration points? Also looking at more Fibre-to-the-X, if you want to reuse existing copper infrastructure. Where do you put your new cabinet locations which require a fiber connection, but the remaining part to your building can be copper. So both in fiber to the home and fiber to the X, this is one of the questions. Then also for your complete area, how do you divide up the area in different clusters? So which homes will be connected to which fiber concentration point? And then also, how do you route everything through your area? So your cables, your ducts, where will you do trenching? Where will you use aerial? Where will you use existing conduits? So all of these questions already need an answer in your initial design stage. Now, where do you start when you're looking at an area and you need to define your initial design? Here we have an aerial view of a particular area. You see your buildings that will require fiber connection. You see your streets. So now, how do you start to do this initial design? Well, with FiberPlanIT, we load in the GIS information, so we have a lot more detailed information. Here you can see the building layouts and also the green dots indicating where we need an actual fiber connection, together with our street information. Then FiberPlanIT will take this information and then determine where trenching is possible and how these buildings should be connected to these possible trenches, and decide how to cluster the buildings together to the different fiber concentration points. So that's also something in a manual design. So how do you, which buildings will be connected to which fiber concentration points, and where will they be located as well? And then lastly, you also need to route all of the different cables, drop cables, distribution, feeder cables, back to your central office. Now, what is the value of using FiberPlanIT in this particular stage of your initial design? Well, normally when doing FTTx design, you have a lot of design guidelines. Well, all of these guidelines will be loaded into the FiberPlanIT rules and can then be applied for every single design that you do. And because FiberPlanIT is an automated solution, all of these rules will be strictly followed. So you will have less design errors, less room for interpretation, because when you make any changes to your network design, FiberPlanIT will check if the rules are still followed, and will give you a warning in case it's not valid anymore. So you will lower your planning time as well, because when an initial design is finished, you need less time to validate your design as well. And also during the deployment stage, you will be able to deploy your network faster and cheaper. You will have less no design errors, which might be only discovered later on if you're doing your design manually. We also have optimization algorithms built into our software solution. And it's also can have a very positive effect on your network rollout, on your FTTx project. Imagining that you do your design manually, following the design guidelines, then if you give your area to design to three different designers, it's possible that they all come up with a valid design, but the design will look a bit different. You will have different ways that they divided up the areas into clusters, different ways for routing the cables, and it's possible that not the three designs will not be alike, and you will only have one design which is the cheapest. Now by using FiberPlan, using the automation and the optimization, you will always come up with the cheapest design. And we have some feedback from one of our customers where he designed an area of 2,500 homes, and we compared the output of FiberPlanIT with the original manual design which was made, and saw that the original design was 8% more expensive than the design calculated with FiberPlanIT, and for his particular area of 2,500 homes, this resulted already in a savings of 200,000 euros on this project. Because as you know, fiber to the home is quite expensive, definitely underground solution. So any percent in savings that you can make for the deployment has already a big impact on the costs of your project. Now, like I explained, FiberPlanIT uses automation to do your design, so you can have a very quick iteration to have a new network design. And let's compare this a bit with manual design process. Now, if you're doing a manual design, you draw your design within a CAD environment, probably, or some feedback that we received is that some people still do manual design in Google Earth, for example. And doing a manual design, normally you can do around 1,000 homes per engineer per month, with the disadvantage that there's still some probably some it's error prone process, and also not that flexible as a process. So doing a manual design is quite time consuming, and then not very scalable. Then if you move manual design to an actual GIS design, so within a GIS environment, normally in most solutions there are some level of automation for creating cables, following a certain route. You can already increase to 3,000, 5,000 homes per engineer per month. But then with a FiberPlanIT design, we have automated steps for preparing the area already, for determining where to put your fiber concentration points, to determine your clusters, also route all of the cables and ducts and so on. Then you can up your efficiency and move to 10,000, 5,000 homes per engineer per month. Most of the time that is spent in doing a design with FiberPlanIT is in preparing the data. So when loading your GIS data, we have some automatic pre-processing steps, but the user can still manipulate this data to make sure that everything is exactly correct as it is in the field. The design itself, as we will see in the demo, typically takes a couple of minutes. And an advantage of doing a design with FiberPlanIT is that you can compare different types of scenarios, different types of design rules, or cost information, or different types of input data as well. That's also something that we support in the FiberPlanIT simulator very easily, where you can run multiple scenarios, compare different types of architectures on one particular area. Now, looking again at proof of concept for a customer where 2,000 homes needed to be designed. Doing a manual design on this particular area took around 2 months, and then using FiberPlanIT, loading in the same type of design rules, doing the calculation was done within 2 days. So also not only during the deployment you will save costs, but also already during your design stage, there's a cost saving because you need to spend less time on one particular area, on one particular design. So yeah, and also your planning time is reduced, and then your time to market will also be reduced. Now we will move to a demo of the FiberPlanIT Designer, where we'll show you how it is done, how the initial design is done in FiberPlanIT. So here you see an area that was loaded in the FiberPlanIT Designer. The GIS information that is loaded is we have building polygon information and also the entry points of the building. In the GIS data, it is available in the GIS data of the address points. It's available how many homes there are in a building. So each multi-dwelling unit is also represented by one single connection. But in the GIS data, it is known how many homes need to be connected, so that we know how to scale the fiber connections and cables. We also loaded in the street centerline information, and one part of the area is also will be an aerial deployment, and here we have information about pole locations as well. Now, within FiberPlanIT, to start off with your initial design, this is sufficient in terms of information that is loaded. To start doing your design, you can use the automated pre-processing steps. First of all, we will determine where the software can place cables and routes, cables and ducts underground. So based on the street center lines, the software can calculate any possible trenching locations by the side of the road. And it also takes into account, as you can see here, the width of the streets. So this is a street with a width of 2 meters. So this is automatically taken into account. Then we need to connect our buildings back to the possible trenching locations. So we need to determine how the cable can enter into the building. And also for this, these lead-ins are created automatically. And what is important is that these lead-ins can still be manipulated, so to say. So, for example, here, the software automatically connects it to the closest trench, but we might know that a lead-in for this building needs to run straight to the side of the road. So this can easily be manipulated and taken into account. It doesn't even have to be connected completely. The software can take this into account. And this we can do for our complete area. So preparing the input data for doing the design. The next step in our pre-processing is creating possible crossing locations. So the software needs to know where a cable can cross the road, and as you can see, a lot of possible crossing locations are created. But as we will see in the final design, not every crossing is being used, of course. Also in the input rules, we can specify an additional cost for crossing the road, which will then be taken into account to determine the amount of crossings that will be needed to lower the costs, of course. Then we also have some pre-processing steps for an aerial deployment. So the software can automatically connect poles to each other. If you don't have these aerial connections as input data, and then you can still manipulate this data as well. So here you can see, let me switch off this information to make it a bit more clear. So all the poles are now connected to each other, and again, like with the drop trenches, this information can be edited. And also we need to know, for these aerial connections, which buildings will be connected to which pole. And also for this, you don't need to do this manually. This is done automatically, and again can be changed. So if you don't want a certain building to be connected to a particular pole, then you can change this this lead into a different pole. The last pre-processing step that we need to do is determine where we can move a cable up or down a pole. So we need to connect our cables, our poles to the underground trenches, so that we can move up and down a pole. So very quickly you can pre-process your area for doing a network design. So with a couple of clicks of a button, you can prepare your area. In a real life process, you will have to inspect all of the data that is created, and can still make some changes, like we did with the one lead-in. You can still make some changes here to make sure that everything is correct. In terms of input data, what we can also do, which is quite important, I think, is determine whether a trench can be used or not. So you can choose to exclude some GIS data of your network design process. So it's a quite flexible system to use. Then next to our GIS data that we loaded and pre-processed, we also need to define the rules that should be followed. So define the type of architecture, and define the cost information of all the equipment that should be used. I've set up one type of rules here. So in this particular demo, we will do a pond scenario where 1/32 splitters are placed in the distribution point. In the FiberPlanIT rules, a lot of parameters can be configured. A lot of cost information can be inputted, and it's a very flexible solution again, and also very extensive, because we for every project that we do, and we've done a lot worldwide, we use the information and type of design rules that the particular customer is using to extend the functionality of our standalone solution. So we build in new types of deployment strategies and new types of equipment that is used, so that every new project can be supported. Also, what can be configured in the design rules is that for every single layer of your network, you can define different types of ducts and cables that can be used, and foresee spare capacity on every level. So within your distribution cables, you can have some reserve fibers, or within the ducts, you can have spare capacity. Also for a distribution point that you want to place, you can make sure that there's additional capacity available there. So quite flexible set of rules. If you have questions on certain rules that can be supported or not, please do ask them here or later on via email. Now,
once you have set up your design rules, which can be done quite easily, quite fast, and then can be reused for every single design that you do, and you have pre-processed your GIS data, we can calculate a network design. So what the software will now do is, for this area of around 1,000 buildings, where we have some multi-dwelling units, I think it's around 2,000 homes, it will apply the design rules that we specified with all of the different restrictions to cluster sizes, also types of cables that can be used in strategies. And it will apply these rules to our GIS data of the area and determine where cables and ducts need to be routed, where trenching is needed, where our aerial routes can be used, and so on. So for this particular area and these design rules, this took a couple of seconds here. Now let's go into a bit more detail to see what the software actually calculated. If we zoom in here, so let me switch off the input data that we defined, and as you can see, all of the different possible crossing locations that were created. Only a few of these are used, so only where necessary the cables will cross the road, of course, to minimize the cost. Now let's look into a bit more detail what was calculated. So for this particular underground design, we see here the different buildings are connected with drop cables back to the possible trench. Here we see this is a to fiber drop cable. Then you have the drop point that's being placed. And all of these drop points and homes are then gathered into one particular cluster for distribution cabinet, which will serve all of these points. And you have the cables, the cables running into ducts. So you have your ducts here and cables running in this particular duct back to our distribution cabinet. And then you also have feeder cable running back to our central office location, which is placed here. So a complete network design for an area can be done in a couple of minutes. Next to this as our plan design and visual representation, you also get a bill of material. So we have an overview of cost information, cost per home passed, home activated of the area, and also breakdown per layer, sort of say, of the network in terms of costs to pass a home, so for the deployment, and also to activate a home. And we have a detailed breakdown of the costs per type of equipment as well. So if we look into a bit more detail, if you have for the drop part, for example, you have a cable of to fiber cable that was specified in the input rules with this particular cost, then you will see here that we need almost 5 kilometers of this type of cable, and this will be the total cost. So very detailed information, and this information is available with every rerun that you do. So with every iteration of a design that you do, you will get this bill of material, and then you can assess whether it's cheaper or more expensive with the changes that you imposed. Now, we have seen how we can do an initial design with FiberPlanIT. Now let's have a look at doing a fine-tuned design. So assume that
you have taken your initial design to the field, done a field survey, and discovered that some design decisions that were made, so possible fiber concentration point locations, so cabinet locations or trenching or so on, was not possible or ideal, then you can input some redlining information so that you can provide information back to the designer, and then you can make your adjustments to your design. When this is done in a manual process, all of the changes will be done in a very local way, very quick and easy changes, but you won't do any general optimization of your network anymore. Now with the FiberPlanIT Designer, if you make any changes to your network design, it will take into account these restrictions and recalculate the complete network, so that you can have some general optimization as well. Now let's show how this is done in the designer. So here we have, and this is the same area, but a completely underground design of the area, and we have some information coming back from a field survey. So here it says serve these homes from DP40 with an indication. So we can have a look. This is aggregation ID 40. Now what we can do in the designer is change the cluster, change the polygon very easily of this particular distribution cabinet. So leave them out of this cluster, and then take them in the cluster of distribution point number 40. Then if we would recalculate, cables will be rerouted to a different distribution point. We will see this in a minute. Now in a different part of the area, we can also see place the distribution point further down the road. So here we have a distribution point, and we can simply move this point to a different location. Now I have prepared the area with these type of changes, so that we can easily compare the change in cost and the change in design. So this was the input that we just saw. So with this particular cost of 2,074,000, and with the changes that were done, so this just has a minor impact on the cost, as you can see, going from 77 euros to 224 euros, and we can load this particular design to evaluate how the design has changed. So as we can see here, we now have this new location for the distribution point for our cabinet, and the feeder cable, the blue line you see here, has been rerouted to connect this distribution point. And then also here, these particular homes that needed to be served from a different cabinet location are now the distribution cables are rerouted to this cabinet, and no more cables are placed in this particular trench here. So very easily, by just simply dragging and dropping, you can take into account these field survey changes. You don't have to change the cables, ducts, trenches itself. Simply by changing the cluster, changing the polygons, you can recalculate your network, and the software will give you an updated network design and bill of material as well. Now let's have a look at Fibre-to-the-X example. So assuming that in this particular example, we assume that there's an existing copper network. We have fiber to the cabinet already, VDSL2 scenario.
And the copper lengths can vary from 10 to 10 meters to 2 kilometers. You can offer a speed of 30 megabits per second. Now, one of the objectives that operators have is to reduce the copper length so that you can place new active equipment and increase the speed to your end customer. And in this particular example, we will look at a scenario where you reduce the copper length to maximum 100 meters. Now, in FiberPlanIT, you can also have an additional setting to make your scenario economically viable. So you can specify the minimum amount of homes that you want to place on a fiber node. And we'll have a look at in the demo what this looks like. So in this particular example, we have our existing cabinet locations indicated with the black square here, and the light blue lines represent existing copper infrastructure serving all of the different homes indicated by the green dots. Now we want to the distance here is quite far. Let's have a look. So to particular customers, this can be up to 440, 450 meters. Now we want to reduce this length and place new cabinets to serve the different homes. And this particular example, we reduce the length to 100 meter and assume that minimum 8 homes need to be connected with a new node, so that you don't, in particular rural cases, you don't need to place a new node for every single customer. Now, this is particularly what it looks like. So the software calculates where new cabinet locations need to be placed. So the connection from the building to this new cabinet is over the existing copper infrastructure, and then a fiber connection, the dark blue line here, is being foreseen from the existing cabinet which had fiber capacity available. So the software determines where these new cabinets need to be placed and how to route, how to serve these new cabinets with a fiber connection. And what we see here, the green dots are within reach, so within 100 meters of our new cabinet. The red dots are not. So that's with the setting of a minimum amount of homes. We'll see that some homes will not be within reach, because there cannot be a cabinet to place minimally 8 homes within reach. So when doing this design, you can still evaluate what the minimum amount of homes should be to have a certain percentage of homes within reach of the 100 meter. So the FiberPlanIT can help you in making this decision and determining where in the end new cabinets should be placed and how they can be served. And this can be done for again for a complete area at once. So for this particular area, you see here in this rural part that it's not economically viable. It's not possible to have minimally 8 homes within the 100 meter reach. So only in particular locations you will have the buildings within reach of a cabinet to assure a high connection. So to conclude this webinar on the FiberPlanIT Designer, as you saw, it can be used in the initial design of your FTTx project. So both for fiber to the home, fiber to the cabinet, fiber to the X.
It increases the uniformity of your designs because we use automation in the software. You specify your design rules, which can be used for every single design that you do. We have optimization algorithms within the software, so you get an optimized design which will save you in cost of your deployment. And also your planning time is greatly reduced, so your efficiency is improved as well. Then for the fine-tuned design, you can easily adjust to field input that was provided, and still have this high level of optimization within your design. So in terms of numbers, okay, we saw for certain real life case, by optimization, we can save 4 to 8% in deployment costs. Also, you can become a lot more efficient. So depending on your current process, you can go 3 to 20 times, do a design 3 or 20 times as fast. And then in your fine-tuned design, you keep your maximum level of optimization while adjusting your design. Now, like I said, we've done a lot of projects already across around the world. So more than 120 projects in 37 countries. So we're a proven solution, and with every project that we do, we improve the software even more. Here are some words from customers that we worked with. So can increase job satisfaction. You can work a lot faster in your design process and lower your deployment costs at the same time. Then some final remarks. If you're interested in the complete planning process, like I showed in the beginning of the webinar, if you have more questions around strategic planning as well, please reach out. In terms of integration, so we have a lot of existing integrations with partner software solutions for field serving or detailed design, workforce management. So also please reach out if you have any questions related to this. Now let's have a look if there are any questions that came in during the webinar. So one of the questions is, can we have mixed between underground and aerial solution? So this is something. It was a very early question. So this is something that I showed during the demo. So you can mix underground, aerial, existing conduits all in the same design. Okay. So let's have a look here. One question is how the fiber concentration points or distribution cabinets are placed. So the software uses the information that was specified in the rules. So there you can specify a restriction on the total size of a cabinet, and also a cutoff distance, so maximum distance from the building to the distribution cabinet. And then it will place it, it will divide up the complete area to different clusters and place the cabinet in an optimal location. And then to pick up another question, can we change its location? So like we saw in the demo as well, you can change a location if cannot be placed there due to local restrictions. You can move that cabinet as well. One question I see here is it possible to load existing information about existing ducts and define a rule to prioritize the use of these ducts? Well, what we do in FiberPlanIT, you can load in existing duct information. That's not something that we did in the demo here, but you can load in this information, and then in the design rules, you can specify the different unit costs for using an existing duct, for using an aerial line, for doing new trenching. And then the software will determine where to place the cables based on this cost information. So it will take this cost information into account for determining the cheapest way to route all of the cables and the duct information. One question I see here, for distribution capacity, I've seen only 128. Is it only one type, or we can use different according to geographical area and network distribution? So indeed, we use one type of design rules in this particular example. So we put a restriction of maximum 128 homes connected to a distribution cabinet. But when doing design, you can specify multiple rules that can be used into one different area. Also, if you're doing a design in an urban area, you can use one set of rules compared to doing a design in a rural area. You can use a different set of rules. So the system is flexible enough to take this into account, and then design the network. One question I see here, what are the options if no GIS data is available in my area? So this is a question that we often get. So in FiberPlanIT, only basic GIS data is needed for a greenfield deployment. So streets and buildings, streets and demand points. In certain countries, you can find a lot of information on OpenStreetMap, so data that is freely available. You can use this data as a starting point, but you will need to enrich this data, because you need to know the amount of homes within an apartment, within a building as well. And this is something that there are different companies in each country that can be used to enrich this data, or you can do it yourself by doing a field survey. But if you have problems in gathering this GIS data in your particular country, please also reach out to us for your specific case, and then we'll try to help you get in touch with the right companies. One last question maybe. So how much does FiberPlanIT cost? Well, we have multiple licensing methods. For bigger projects, we can offer seat licenses, but also for smaller projects, we can charge per particular area. So depending on the amount of buildings there are in your area and that you want to do a design on, we can charge per demand point as well. So flexible, we have very flexible licensing systems from smaller projects to larger projects. If you have any further information that you need, or you want to discuss your own projects, you can reach me via mail or via our website. You can also contact us. Now, I would like to thank you for your attention. So later this week, you will receive the recording of this webinar.
And any questions that I did not handle, I will try to handle via email. Thank you. Goodbye.